Hey there, Algebra. Unit 1, Lesson 10. So let's talk about a fun game. Several video games are based on a genre called Battle Royale, in which 100 players are on an island and they fight until only one player remains and is crowned the winner. This type of game can often be played in solo mode as individuals or in team mode in groups of two. Um, Thinking of Ready Player One, yeah, sort of the battles at the end, but I digress. What information would you use to determine the top players in each mode, either solo and team? Explain your reasoning. Like how would you determine, get my pen going, the winners? Oh, that's really thick. Um, I don't know. How would we determine the winners in each mode? Maybe the number of players defeated. Again, if we were face to face right now, oh gosh, that should be an F. Ha, sorry. You would explain to me how you've experienced this playing video games in your world, right? Because I will admit, I don't play a lot of video games at all. I tend to get bored easily. And I'm really bad at the ones where it's like all of us fighting against each other. Really bad. So, yeah. Um, so maybe the number of players defeated, maybe the number of wins. Okay, maybe that would work. If we think with the number of wins, like if you're a really good player, you could defeat a lot of other players but still not win. So that one might not work. If it were me, so I've actually played paintball in the past, and I'm terrible at it because I don't know strategy. I'm not a very good aimer. I get nervous quick. So I would just hide until the end. I mean, somebody would always find me and I would die, but that would be one way to win. You aren't defeating any other players. You're just hiding until the end, and you win. Is that Would you consider the hider a top player? Probably not, right? So that wouldn't work. So yeah, that's a good discussion on that. Now, number 2, one person claims that the best solo players play game A. Another person claims that game B has better solo players. How could you display data to help inform their discussion? Explain your reasoning. Let's move this up a little bit. How could you display data to help inform the discussion? Explain your reasoning. Well, we could create a dot plot of game A and game B. A dot plot that, let's see, just showing solo players and what they're doing. I don't know what we would be displaying. Or, here. And it could show you maybe things that visually would be, you could have a discussion. Dot plots are the number of other players defeated by the top 100 players in each game. A dot plot of the number of other players defeated by the top 100 players in each game. Yeah. And then we could compare. These are the words I want you to remember. Compare the center and variability. Okay? Compare the center and variability of each game A and game B. Okay? That's one way to do it. Let's get into some actual examples though. All right? Okay, so separated by skew, your lesson might say 10.2. where mine just says 2 because we're in lesson 10, so the curriculum doesn't feel like it has to tell you that again. All right, now use technology to create a dot plot that represents the distribution of the data. Then describe the shape of the distribution. Hold on a second. Just so you know what I'm doing, this right here is, it's our calculators. And I was trying to see if there was a dot plot. There isn't. So we're going to have to create one all on our own, and it's okay. So I'm going to make this go away, and I'll be right back. All right, we are going to practice. Let me move my head. Let's go ahead and practice putting information in because we're going to get some, when we run our statistics, we'll get some interesting information from it. So if you remember, we hit Stat, and number 1 is Edit. Okay, now you're going to arrow up and hit the Clear button, and it'll clear, and then arrow down, sorry, and it clears the list. Now we're going to go ahead and enter the list. Sorry, let me find it. I'm going to use my keyboard. 6, enter, 7, 8, 8, 9. I think there's more than one 9. Yep. Oh gosh. Okay, hold on. That's too small. So I have 1, 2, 3 9s. 1, 2, 3 9s. 1, 2, 3, 4 10s. 3 11s. 2 12s. Okay, now we're going to go ahead and run that, and we hit Stat, Calculate, arrow over to Calculate, and then one variable statistics. Okay, list 1 is correct, so we want to enter, enter, enter. Now let's write down some information over here. All right, the median. Oops. Gosh. The median is 10. Nope, there's nothing else running. I might have to start using a different program. Okay, let's come over here and find the mean. Sorry, I'm struggling today, aren't I? X bar is 10. That's new. I'd like you guys all to realize that or learn that mean is the same as X bar over here. Okay, so we know our median is 10 and our mean is 10. All right, moving on. I did not create the dot plot though, did I? Okay, so let's do that. I apologize. So I don't need the calculator. It's okay that that disappeared. I'm going to go ahead and do this. It looks like our smallest value is 6. And our biggest value is 14. There's 1 6, 1 7, 2 8s, 3 9s. See how my dots are the same horizontal level? 4 10s, 3 11s. Oh, it looks very symmetrical, very bell-shaped. 2 12s, a 13, and a 14. It's perfectly symmetrical and perfectly bell-shaped. So we could say symmetric and bell-shaped. And then we found the median and the mean, and it's not a mistake that they're the same. same values because our data is symmetric and bell-shaped. So it's going to give us the median and the mean should be equal when your values are symmetrical and bell-shaped. All right, let's see, what's the next question? Find the mean and median of the data with 2 additional values included as described. So first, we're going to add 2 values to the original data set that are greater than 14. So if we did that, make this a little bit longer. Let me change colors. So, I mean, we could add 2 dots at 15 or a 15 and a 16. Okay, are we symmetric now? If I cut it in half, can I fold it on top of each other? No. All right, so let's go over here. I'm going to go back to Stat, Edit, and add some. We did a 15 and a 16. Oops, sorry. 15, 16. Now we can do Stat, Calc. Okay, the X bar is now 10.55. And the median, let's see what the median was. 10. Remember, the median is the middle number. So you line everything up, smallest to biggest, and then you find what the middle number is. Okay? So when we added 2 data points that are greater than 14, our mean should shift to greater than 10, right? And it did. And then our median actually stayed the same because we have enough values at 10 that because we only added 2, we still have a median at 10. To find the median, I can cross off 2 dots, 3, 1, 2, 3 dots, 1, 2, 3 dots, 1, 2, 3 dots, 1, 2, 3, 1, 2, 1, 2. We still have a median of 10 because we only added 2 to the right. All right, what's the next question? Add 2 values to the data set that are less than 6. Okay, got lots going on here. Let's go ahead and erase these. And let's do green. We'll just add 2 here. Now, what's going to happen to our mean? Our mean should drop below 10. And our median should stay the same. Let's try it. So Stat, Edit. I'm going to go to the end of list 1. Instead of 15 and 16, I'm going to type in 2 5s. And then do Stat again and calculate 1 variable statistics. My mean is now less than 10, and our median is still 10. Makes sense, right? All right, what's the next question? Add 1 value that is greater than 14 and 1 value that is less than 6. What should happen? So if I delete these and I add, I'm out of colors. Let's use the black ink. I'm going to add 1 dot down here and 1 dot up here. Well, then everything should stay the same. Our mean should stay at 10, and our median should also stay at 10 because we added a dot to each side and it stayed symmetric. Cool. Add the 2 values, 50 and 100 to the original data set. So that means that I'd have to delete these, and I don't have enough space to do this. But basically, we're adding 50. I think I need to break that. That's a way to signify your number line is missing, like what you write for your number line is missing some data, is to draw that little break. I'm going to draw it a little bit better so that you see it. What you really do is number squiggle, okay, sorry, line squiggle. It just shows that you're not showing all the data. All right, but let's go over here. Okay, stat, edit. I think I want to delete those two 5s. I'm going to put in 50 and 100. What should happen? What do you think? Okay, what's going to happen to our mean? It's going to be bigger. And what's going to happen to our median? It shouldn't change because you're adding just 2 numbers to the high end, which we did when we added a 15 and a 16. And our median did not change. But our mean became greater than 10. Now we're going to add 2 numbers even bigger than that. Our mean should be much bigger than 10, and our median shouldn't change. Let's see. Stat, calc, 1 variable statistics. Okay, our mean is 16.5, and our median is still 10. So here we're going to say our mean is 16.5, and our median, oh, for goodness sakes. I always think that's because I have other things running in the background, but there's nothing running except that calculator. The median is still 10. Okay, share your work with your group. What do you notice is happening with the mean and median based on additional values? We talked through each example, so I think we're good. Change the values so the distribution fits the description given to you by your teacher and find the mean and median. Okay, hold on this for a second. I'm writing the word hold. Find another group that created a distribution. Okay, I'll be right back. All right, here's the A, B, and C are scenarios I would give you to talk about number 5. Number 5 says change the values so the distribution fits the description given to you by your teacher. Then find the mean and the median. If we look at A, skewed right with most values at 10. If I were to draw this, okay, I'd still have most values at 10. That's going to be a bunch of dots. But if it's skewed to the right, I can have a few values here. That's a 12. Okay, does that make sense? Let's see, this is the point that I want to make. 2, 3, 4, 5, yep. A few 11, 12, 13, 14, 15, 16, yeah. What I would like you to write down, first of all, that's a 16. We're not symmetric, so our vocabulary, I'm trying to remind us of right here. We are not symmetric. We are skewed right. It is not bell-shaped. It is not uniform, and it is not bimodal. But what is our mean and median going to be? So for this one, we could say our mean, I'm not going to give exact numbers. Our mean is going to be about 11, I don't know. And then our median, remember mean is x bar. Our median should be smaller than that. Okay, so our mean is bigger than our median. That's what I want you to take away. Our mean, I'll write it right over here. When we're skewed right, our mean is usually bigger than our median. All right, skewed left. And it says most values of 10. So I can repeat this. I don't know, there's, I think, 5 dots. And I'll even put those 11s in there. But now we're skewed left. So that's 10, 9, 11, 8, 7, 6, 5, 4. So for this one, if we calculated it, we'd have a mean of about, I don't know, 8.6, and a median of about 9. So when we are skewed left, our mean is less than our median, right? Okay. Now, how about this last one? Symmetric with most values at 4 and 16. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it doesn't matter actually what I do in the middle. Okay, we're not going to have very many values in between. I don't know. Symmetric. So I can actually cut it in half and fold it, and it's going to be a perfect reflection. Perfect. It's going to be a pretty perfect reflection. Okay, when most values are at 4 and 16, our median and our mean are still going to be the same. We can say they're both 10 because it's symmetric. So our mean equals 10 equals our median. All right, our mean and our median are the same and they're both 10, but this right here is bimodal. There are 2 peaks, so it's bimodal. All right. All right, let's move on. Did I answer all the questions? 6, find another group. It's okay. We talked about all of them. All right. Oops, I hit a wrong button. 10.3. Plots matching measures. So create a possible dot plot with at least 10 values for each of the conditions listed. Each dot plot must have at least 3 values that are different. Okay? All right, so I'm going to push pause and create some of these, and then we can talk about them. All right? All right. So what we see here, number 1 is a distribution that has both a mean and a median of 10. I drew a dot plot that is very, oh, that should be in blue, very symmetrical. Okay, I just put a whole bunch of dots at 10 and evenly spaced dots to the left to the right, right? So that is our median equals, our mean equals our median. Okay, very symmetrical. The next one was a distribution that has both a mean and a median at negative 15. So here we're at negative 15. I went 2 below and put 2 dots, 2 below, 1, 2, 3 below, 2 dots, 2 below, 2 dots, 1, 2, 3 above, 2 dots, 2 more, 2 dots. So I'm very symmetrical. Okay, I'm not bell-shaped, but I'm symmetrical, and my mean equaled my median. The next one is a median of 2.5 and a mean greater than the median. So when my mean is greater than my median, I am skewed left. So that's what we learned way back up here. Yep, we were skewed left when our mean was greater than our median, when we added more dots down here. You guys would have written that down though, right? And this last one, a median of 5 and a median greater than the mean. So I'm going to say the mean is less than the median because we are skewed right. And that's what I made. I made a skewed right one. So I could draw a curve up here and go down. I would draw a curve up here and go down. Okay? So lots of really good vocabulary words in this lesson also. Sorry, I want to make sure I hit everything. Yep, lots of really good vocabulary words that we need to review. Let's see, how about for the first and the second one? What do the distribution shapes have in common? We can say that they are symmetrical, all right? The mean and the median are the same. What do the shapes of the dot plots have in common when the mean is greater than the mean is greater? I think that should have said, I'm reading my notes, greater than the median. When the mean is greater than the median, we are skewed. Sorry. Let me double check here because I wrote something down wrong. I want to make sure I got it right. Yep, mean is greater than median because we're skewed right. So this is written backwards. I'm sorry. And again, I would love to rewind and re-record it so you didn't know I made a mistake, but that is not realistic. So when our mean is greater than the median, we are skewed right. And I wrote it again. Okay. It's a hard thing to memorize. So when we're skewed left, we go that way. When we're skewed right, we go this way. And we can talk about the why, okay? When distributions are skewed right, they will likely have a mean that is greater than the median because the values to the right disproportionately impact the mean. Skewed right, the values to the right disproportionately affect the mean, which is the average. Okay, that's why your mean is bigger. When distributions are skewed left, they will likely have a mean that is less than the median because the values to the left disproportionately impact the mean or the average. Okay, I'm glad we talked through that. Just to summarize, one more thing I want you guys to write down. I can move. I lost my mouse. Okay, we'll just do this. Something else I'd like for you guys to write down that's super duper important, and I know this lesson's a tad bit longer. My median is preferred. That's 2 R's, isn't it? 1 F and 2 R's. So the median is preferred to the mean when it's skewed. It's a better measure of center when it's skewed, okay? Measure of center. When we have an extreme value present, why is the median preferred to the mean? Okay, that's another important one. When we have an extreme, oh my goodness. And that would be if I had a dot plot and I had everything like nicely everywhere, and then I had this value over here. That's an extreme value. So when an extreme value is present, um, the median is preferred. I'm going to pause and write that. Sorry, writing became very difficult. So when there is an extreme value present, which I drew here, like a normal dot plot with this random dot so far away, it's extreme. The median is preferred because this extreme value has a greater effect on the mean or the average than it does on the median. When you have that extreme value, sort of like the 50, excuse me, sort of like the 50 and the 100 that we added to that one example, it didn't change the median at all because it's still, you're going into the middle value, but it did affect the mean quite a bit, the average. So when there's extreme values, we want to talk about the median. And the last thing that I'm not going to write down, when data is symmetric or about symmetric, the mean is preferred because it takes into account every data value. Okay, so the mean is preferred when things are symmetric. So I'll try to write it down. Hold on. So when it's symmetric, we like to talk about the mean because the mean takes into account every data value. Okay, cool. Good job today.